In section 1.5, we want to learn how to use a problem-solving plan to solve problems. What we're really looking at is how do you go about taking real-life problems, word problems, and having a plan for how you address accessing the information within those problems and putting it into a form in which that you can solve. The key vocabulary for this section is just formula, and we're going to get into the formulas, some standard formulas in just a little bit. But when we talk about a problem-solving plan, this is by no means the only way to go about it, but this is a pretty solid place to begin. As you go through and you practice, you will probably develop habits and things that work best for you. You should always work with the things that work best for you. And, you know, these things are advice, but they're by no means is this the only way to go about it. So the first step is to read and understand. So you need to have really good reading comprehension, and you need to read carefully. So you need to read the problem carefully, figure out what it is that you know and what it is that you have to find out. Step 2 would be to make a plan to decide how is it you're going to go about solving the problem. 3 is executing the plan, so going ahead and solving the problem. If you can't solve the problem with your initial plan, then you need to adapt and try a different plan and keep working at it until you've found a solution. And finally, you want to go back and you want to check to make sure your answer is reasonable. Does it actually answer the question? Okay, sometimes as we're working on these types of problems, the equation we write doesn't actually answer the question that was asked. So you also want to make sure that the solution you found, is it the answer, or is it just some key information you needed in order to answer the question? So I'll give you examples of those as we move forward when they come up. These are some formulas for basic things. So a formula is an equation that's been put together to do repetitive types of calculations that are common. So this first formula that's here is a formula for converting from Fahrenheit temperature to Celsius temperature. This formula, interest is equal to principal times rate times time. This is a formula for simple interest. Distance traveled, distance is always equal to rate times time. And profit is equal to income minus expenses. So these are some really basic formulas. By no means are they comprehensive. There are lots of formulas. But this is a good place to begin. And what's important with formulas is I have here a formula that is made for me to plug in values of Fahrenheit and get out values of Celsius. Okay, so in this case, Fahrenheit has been made the input variable and Celsius is the output variable. I can manipulate this equation to change that around so that it's made to input Celsius and get out Fahrenheit. So you want to know that these formulas are great and they're important, but they can also be reworked to suit whatever situation you're in. So here's a problem. We're going to read the problem. We're going to start working on making a plan. So thick crust pizza requires about 0.15 ounce of dough per square inch of surface area. I have 2 rectangular pans, one that is 16 inches long and 14 inches wide, and one that is 15.5 inches long by 10 inches wide. How much more dough do I need to make a thick crust pizza in the larger pan than in the smaller pan? Okay, so how much more? So now what we're talking about, when my question says how much more, I'm going to be comparing 2 values, right? And what values? How much crust for the larger pan and how much for the smaller pan. Okay, that's what I have to find out. So I've sort of skipped down here and read to understand what do I want to find out. I want to find out the difference, right? When they say how much more, that's found by finding the difference between the dough, I can't write as fast as I'm going to talk, the dough in the large pan versus the small pan, right? Large versus small. Sorry, I'm going to abbreviate. What do I know? Let's go back and look at what we know. We know 0.15 ounces of dough per square inch of surface area. Okay, so if I know the surface area of the two pans, then I'm okay. So I know that here I've got 16 inches by 14 inches, and here I have 15.5 inches by 10 inches. Okay, great. So that's the stuff that I need to know. What I know is I know the size of the two pans. I know the size of the pans, and I know how much dough per inch, per square inch. Okay, that sounds like all the information that I really am likely to need. So let's go through the plan. I'm going to calculate the square inches in the large pan. That's a pan, not rand. Okay, in the large pan, minus the square inches in the small pan and I need to multiply that times how much dough per square inch, because they want to know how much more dough. That would be how many ounces. I need to know the difference in the square inches times the 0.15 ounces per square inch. Now, is that the only way to do the problem? No, not at all. Instead of just calculating square inches in the large pan, I could find out how much dough in the large pan. And I could find out how much dough for the small pan and then do the subtraction. So this is not the only way to lay it out. You should do whatever makes the most sense to you. I just figured if I'm going to have to multiply times this decimal, I might as well do it at the end, so I'm multiplying it times a smaller value. Okay, so now let's solve the problem. I already sort of wrote the verbal model back over here. Square inches in the large pan minus square inches in the small pan times the number of ounces per square inch. That's what we're going to figure out. So we have 16 times 14 minus 15.5 times 10 times 0.15 ounces per square inch. Or I could write that as inches squared. Okay, so 16 times 24. Or sorry, 16 times 14. That's going to be 160. It says 10 times 16 is 160 plus 4 times 6 is 24. And if I carry the 2, that's going to be 64. So this total is 224 minus 155, all times 0.15 ounces per square inch. Right? This is, of course, going to be in inches squared, so this is all in square inches. So 224 minus 55 is going to be 969 square inches. Times 0.15 ounces per square inch. So I know my square inches are going to cancel and I'm going to get ounces. And I'm going to multiply 69 times 0.15. Oop, made a mistake. 69 times 0.15. 10.35 ounces. Okay. Now the last thing I want to do is I want to go ahead and look back and see, does that make sense? Does it make sense that 10 ounces is the difference? Well, if we think about it, you go, well, this one, 224, that's going to be, probably 30 some odd ounces, and this is about 20 ounces. That sounds about right. I'm just estimating the 15.15 times these values. It sounds like it's going to be about right. So it's a logical answer. I don't have any type of an equation that I could plug it back into to check other than the one I've already used. So there's not a lot else I can do, but it's a reasonable amount. Okay, so we've gone through, we read the problem, we discerned what we knew, what we needed to find out. We came up with a plan. And remember, this was not the only plan that would have worked. There were other plans that were equally viable. This just happened to be my plan. Okay, we went ahead and executed the plan and solved the problem, and then we checked it to some extent for, is it a logical answer? Is it valid? If I'd made a mistake, if I'd forgotten the decimal and I'd come up with 1,000 ounces, well, that wouldn't have made any sense, and hopefully I would have caught it at this point when I looked back and thought about it.